Well, first, I think I promised you last time that on occasion I tend to go off topic. And have anybody ever heard of the Royal Naval gun trials held in the United Kingdom? You ever seen that? Pretty amazing stuff. It's only about a 6-minute video here, but
I was in ROTC drill team.
yeah, it's pretty amazing what they're doing. It basically started from a tradition back in the Boer Wars. You guys ever hear of the Boer Wars down in South Africa? There were apparently 2 different wars down there. They were fighting the colonists and stuff like that. But apparently there was an occasion where I think the town was called Leesburg or Leestown or something like that, or maybe it was something else. The army was under siege there, and they needed some relief. And a couple of Navy ships, British Navy ships, decided to pull off some of their artillery or their cannons off of the ships and transport them over some pretty rough terrain to this town. And they got there in time to basically save the battle by firing off the appropriate volleys at the right targets at the right time. And it was pretty involved, and these cannons were not designed to be hauled around the country or overland or anything like that. And so they did it mostly by hand and on small ships and stuff like that, or boats. And so they've been doing these competitions ever since. And when you watch it, these guys, they're at breakneck speeds, and it's out and out crazy. It's amazing what they do. This year, 1999, was the last year they used full-size cannons, because now they've gone to the lighter, more portable cannons that they use in the military today. But this is the last year they actually used a cannon barrel that weighed like 900 frickin' pounds. And the funny thing about this is the cannon barrel and most of the equipment never touches the ground other than the wheels and the guy's feet. So I thought let you see this, because it has absolutely nothing to do with Unix. Absolutely nothing. But who knows? It's probably running on a Unix server. Let me get it where you can see it. And see if I can get the volume to go. Everybody see it okay? I love the way they march.
The traditional march on to Hearts of Oak, and the line from it, "Come cheer up, my lads, 'tis the glory we steer," seems particularly apposite tonight. He's had the role for 17 years, and Lieutenant Commander Ken Mathers takes charge of the last run of a competition which has been part of the Royal Tournament since 1907. And the last
pretty big cannon.
Of some 15,000 men who've taken part in this trial of strength, verve, determination, sheer guts, prepare to give their all. The atmosphere is tingling, the tension palpable in the crowd as well as down there on the arena. Now come the 2 trainers to report they're ready. Petty Officer Mac McShane of the Fleet Air Arm, Chief Petty Officer Pat Patilla of Portsmouth. Each has had the run 6 times, and they can hardly make themselves heard in the noise. The thunder flash is lit, and they'll be off at the bang. First to the home wall, they round it, and then everything has to come over the top of it. Neck and neck at the opening, and they go then forward to the home ramp, where a 28-foot spar is attached to sheer legs, and the first man will get
this is the
across
best part.
28-foot, supposedly bottomless pit. Up goes the spar with the sheer legs. Who's over first? It's Portsmouth first to land a man. Now in goes the 10-foot spar on the enemy ramp. The wires are established, and here come the men and wheels on the Traveller. The wheels 120 pounds each. The gun carriage will be next, 350 pounds. And the heaviest part is still to come. Absolutely nothing in it at the moment. Here's the barrel. Over 900 pounds. And down it goes into the carriage. Now the other wheels, they call them the speedy wheels, because they're taken straight to the hole in the enemy wall, and everything has to go through there. The limber last to arrive, that's just 345 pounds. The gun and the carriage.
See, everything has to go through that hole.
Arm of gain time here. They're ahead of Portsmouth. They get to the enemy line where they have to fire 3 rounds. Limber must arrive there in time. Everybody kneeling. Definitely the fleet air arm just ahead. Had a moment to catch the breath before the run back. Empty cartridges away, and the thoughts of the men who inspired this race with the carrying of naval guns to help relieve Ladysmith from the Boers a century ago must be a million miles away. They came from HMS Powerful and Terrible. Well, who's feeling what now? And the times, 1 minute 25.66 for Portsmouth, 1:23.8 for the Fleet Air Arm. They're up by 1.86 seconds, no penalty points. The bugler sounds retire, wait for the G-note. And it'll be over the enemy wall this time. And the Fleet Air Arm slightly increasing their lead. That's been a good wall for them, the enemy wall. First wheels are away. Limber follows them this time. Head down as the traveller comes in. Every man doing his job, and that's what is absolutely vital. Over now comes the barrel, and that'll be slung under the sheer legs to await the carriage. Portsmouth are catching up. They may even have gone slightly ahead. Here comes the carriage. Well, there's very, very little in it, but I still think Portsmouth have moved up a little bit. It's in under the gun. The last 2 wheels come, and now they wait for the man called the Flying Angel, who comes with a 10-foot spar. And down will crash the sheer legs. They get to the gun, they've got to be all needing 3 more runs to fire. It's so, so close. And we're having the cracking final run that history demanded. Just the home run remains. Just, how dare I? And they wait at the home wall, through which everything this time must go. And Portsmouth have closed the gap. 0.6 of a second divides the 2 teams. They were faster on the run back, 59.81 to 1 minute 1:07. Still no penalty points. Everyone now poised for the last notes from bugler Jesse James, who will sound the ceasefire. And through the wall they go. And the gun is put together again. Away go Portsmouth, but Fleet have the slightly tighter turn, and I think they're going to do it. It's the axle to cross the line, and it does so now. It's over. They run down and wait for the official result. What a race.
I always find stuff like that
But as
fascinating.
they
They're
come
just
back, the crowd
not
are
much more to
their
go on
feet.
this. But kind of interesting stuff. I don't know how many of you guys ever been to England. Yeah, me. Many times, unfortunately. Usually that's where we'd stop on the way to Saudi Arabia or something like that. So anyway, occasionally I'll throw stuff like that out during the middle of class. Some of it will be Unix related, some of it will be computer related, some of it will be geek stuff. Somewhere down the road I'll show you a interesting experiment some people did up in Scandinavia, sending ICMP ping packets essentially via carrier pigeon. And they have a whole website dedicated to it, so if you happen to Google it up, it's kind of neat stuff. So there's a lot of trivia. One of the things I've always liked about Unix is that there is always some interesting stuff going on if you pay attention, if you just happen to open your mind and see what's happening. One of them I'll talk about a little bit today. Let me get this thing started here. I wanted to finish up the last couple slides because I kind of rushed through them, and I wanted to get a couple points across before I go into kind of a repeat of a little bit of what we did Tuesday, and then get into some more interesting stuff having to do with the operating system. But the key here on this first tenet was small is beautiful. All the programs written in Unix are very compact, very small, and they essentially do just one job and do it very well. They don't try to be a Swiss Army knife for everything you ever wanted to do about text editing or stuff like that. There's a slew of commands, and a lot of them are very useful. And I'll talk more about it later, but one of the key factors on a lot of these commands is what they call standard in, standard out. The information that goes into that command processes is done in a standard format. And when it comes out in a standard format. And you can take the results of one command and pipe it to another command, and pipe it to another command, and pipe it to another command to achieve your end result. Some of it has to do with text processing. We'll do one of our exercises we're going to do, and I'm not really letting the cat out of the bag yet, but it's rather involved. It uses a lot of different commands. You're going to have to compile a program to make it work. But bottom line was, back in my network security officer days, which I ran across a situation where people were asking us to open up our firewall and our network to a very large number of addresses. And it was from an individual who I still know today and I respect greatly, even though he was down in Montgomery, I was here at Oklahoma City. Very, very smart guy, but not real security conscious. And he wanted us to open up all of these addresses in our firewall so that based on users in the military, and he said all of these addresses or address spaces equated to pretty much all of the .mil domain. And in reality, there was only 1,200 users that really needed to get to this application worldwide. And yet they wanted us to open it up to multiple millions of IP addresses just so 1,200 people could get to it. So I wrote a script that would take all those subnets and parse them, determine out how many usable addresses were in each subnet, then add them all together. And then I took that to our director or commander, and I showed him, says, they want me to open up for, I forget the number, and off the top of my head I'll just say 2.5 million IP addresses so that 1,200 users can get to an application. I don't think that's a safe thing to do. And he agreed with me, and so we forced them, the application owners, to go out and find out where all their users are coming from. Now this was done back in probably 2002, I want to say, just after I became an NSO. And we were just there beginning to get to where we are today in terms of threats on the internet. And they were just starting to surface back in those days. And so it was a good thing that we didn't open up to that many addresses, because years later, not too many years later, actually, a large number of the Department of Navy systems got hacked. And then it wasn't too much longer after that some Army systems got, and it's gone on and on and on. And people are getting smarter and smarter and smarter about it, but every time they get smarter, it's always at the cost of some pain suffered the previous to that moment that they got smarter and became more secure because somebody broke into their system. So I'm going to show you how you can do all that in a script. I'm going to show you how you can do it on the command line. I'm going to tell you how you can write a script. And then when we're all done, you'll have a script that's got maybe 15, 20 different lines on it. And then I'll show you how to take all that information and combine it into one single on the command line script. Not really a script, just an entry. Taking one command after another and piping the input from one into the output of the next, or rather vice versa, the output of one into the input of the next program, to another program, to another program, and end up with the results. And so basically we'll take a large number of subnets, we'll count up how many addresses are available, we'll add them all together, and then we'll go ahead and present that as the answer, that it was X number of addresses that were involved in those subnets. It's an interesting thing because it teaches you the concept of how all these commands can get tagged together. And I'll give you a couple of demos on that today. If I haven't had a chance to check to see if I can get into my server like I wanted to, but anyway, small is beautiful. Program's small. Do one thing only. Do it very well. And prototype portability. That's NA. Shell scripts. You can use shell scripts to do a lot of different things. I have a shell script that runs on my computer at home every night at 2 o'clock. Well, actually every morning at 2 o'clock in the morning, and it determines sunset, and sunrise for that particular day. And then it takes and creates 2 cron jobs, which is basically scheduled jobs to run, one at official sunset and then another one at official sunrise. And the one at official sunset goes out and turns on a number of lights in my house. Have anybody ever heard of X10? Nobody. X10 is a protocol where you can send signals, and the newer versions of it, you can send 2-way signals, where you can send them over your electrical lines to a module you have in an outlet that you plug your lamp into. Or you can replace the garage switch for your outside garage lights with one of these modules. And you can still turn it on and off manually, but you can also send a command from your computer to a receiver plugged into an outlet, which I've got in my office, and I got a little thing stuck into my serial port on the back of my computer, and it sends an RF signal to that receiver. The receiver then sends a signal out over the electrical lines, and the lights will go on and off. And one funny thing that if you're not an electrician, you don't know this until you run up against it. But everybody knows that the normal circuits or power in our houses, AC power, is 110, right? But it's actually 220. There's 220 volts coming in, and it's split into 2 different areas. And there are certain appliances that use 220. Appliances like, the dryer uses 220, not 110. And when I first set up my little X10 modules around the house, some would work and some wouldn't. And then one day I correlated the fact that they would all work when the dryer was on, because the dryer was bridging the 2 110 circuits. So then I had to go out and buy a bridge that would bridge it 24/7 rather than run my dryer all day long, So I mean, but all that is done, behind the scenes is a script on a Linux box that's been sitting on my desk for years. Right now, currently, I have let me see. I think I have 5 computers in my office. 3 of them are running Linux, and then I run one server on the internet. I've been running it on there since 1995, and they're all running one version of Unix or Linux or another. I forced myself to try in the older days, I used to force myself to try different flavors of Unix. So I've tended, and I talked to somebody about this on Tuesday after class, my flavor of Linux, it would be Fedora nowadays, and Red Hat. Now Red Hat has gone commercial, but they have a offering that is open source called CentOS that's derived from the Red Hat server line of software, and that's the one I run on the internet, and then I run Fedora at home. So those are just some of the things, like I said, scripting is a big deal. You can use it a lot, and here they're saying leverage it, but it's very, very useful. We'll talk a little bit about the different shells here later on. Okay, this one here did actually talk about the standard in, standard out, and we'll look at the standard error in one of our exercises as well. You can use a script to detect what kind of error you got to determine whether or not you continue with your script, or whether you abort, or whether you try something else. Like, is a file missing? You'll get a standard error if the file is missing that you're looking for. And these are some of the lesser tenets, but that's not important. But again, I want to reiterate, small is beautiful, and just doing one thing and doing it very well is the whole premise behind Unix. Some of the other things that talking about is that if you stop and think about it, small is beautiful, and that concept kind of rolled off the assembly line years ago when the Volkswagen Beetle came into production. I mean, that was the first small car that just didn't have a lot of frills to it, but it did one thing: got you from point A to point B cheaply and easily. Maybe not safely, because they kind of folded up like an accordion in a crash. But the Mini Cooper, or Fiat Select Car, there's a couple others out there. But the whole idea was just keep it small, keep it beautiful, make it functional, don't put a lot of stuff on it. Okay, let's see. All right, so that's all I wanted to cover on the last part of that one presentation. But what I do want to do is get into this week's, and it'll be a little bit of a rehash in the beginning. Talking about Unix again. We're going to talk about how Linux relates to Unix. Well, I've already been doing that a little bit on Tuesday and some more today. But I will explain the functions of the Unix shells and what the story is behind there, and the different options for connecting to a Unix system. And I'll demonstrate one of them here today. Are any of you familiar with Secure Shell? Telnet? Yes. You know what Telnet is? Secure Shell is an encrypted telnet, if you will. But it's a little more than that. But for the most part, simply said, that's what it is. Number one, never use Telnet. Unless you're just saying, I want to see if a mail server is working. You can Telnet to port 25 and play with it a little bit. Or if you want to see if a web server is working, you can Telnet to port 80. But if you're going to do actual logging in, use Secure Shell. And there's various versions of it, and you don't want to use the early versions because there's security holes in them as well. Okay, let's talk about some of the syntax for some of the commands. You know, come next Tuesday, you'll get into your systems, your images, and we'll start doing. We'll have an exercise next Tuesday. I'll have you guys doing a few things at the command line to kind of get used to how things go. Again, I'm going to reiterate: it's not going to be GUI. It's not going to be pretty. It's just going to be text. That's the strength and the beauty of Unix. That's where the operating system is. We're going to talk about some of the other commands. Date, the date command. Basically, that's a pretty simple one. You know what it is. It tells you what date it is. There's a little more to it than that. It does other things with the date. Calendar. Who basically tells you who's logged into your system. Unixes have always been a multi-user system. So if you're logging into a well-used server, you type in who, it'll show you everybody that's logged in. Man. Anybody want to take a guess at that one? Manual, yeah. Man page. Basically, every Unix command has an associated man page with it, and sometimes multiple man pages, because the man pages are divided up into categories, and we'll get into that too. What is? It's kind of a program that will tell you what something is. If you say, what is MAN? What is man? It'll come back, and it actually goes to the man page, reads the very top line off the man page, which is a brief one-line description of what the program does, and it'll give you that. So if you don't know what, let's see, what would be a good CP? If you don't know what CP means, you type in what is space CP. It should give you an answer. Now, I can't swear this works on Fedora 21 because I haven't tried it yet, but it's always worked on all the Unixes I've worked on before. So I'll show you how we do basic command line editing operations, and then how we can put multiple commands on a single entry. How to recall a command from the command history. If you guys notice that Microsoft Windows, when you open up a DOS window with a command prompt, you have a history. It's kind of a kludged version of what Unix has done for years, but it's not a very good version. The autocomplete, Windows took that from Unix. Or if you type in, like if you want to rename a file, and you type in the first couple letters of the file and hit enter, it'll type the whole thing out. What I noticed today is there were two files I wanted to copy, and one had a 1 at the end of it, and one had a 2 at the end of it, and it didn't give me a choice. It went to the first one. Now, if I wanted to copy both of them at the same time, like I can do in Unix, it'll stop when I hit return to autocomplete. It'll stop not quite at the end. It'll stop one character short, and it'll give me a choice. So, okay, you got a 1 and a 2. So now it's my choice of putting 1 or 2 or an asterisk if I want them both copied. So, and we'll, again, next Tuesday we'll log in and log out of Unix. Tuesday we talked a little bit about operating systems and what Unix is, and I think everybody understands what an operating system is. It's basically an interface for all these particular devices to communicate to the operating system. So the operating system will talk to your CPU, your monitor, your keyboard, your mouse, your printer, your disk drive, and do all the things you need it to do. Basically allowing the users to get access to those peripherals. Uh, Everybody knows what a PC is, so that's kind of a OBE. This is an idea what some of the mainframe computers, IBM System 370, when I first started flying AWACS, that was the computer on board the plane. It's an IBM 370. Obviously, it was hard for not only electromagnetic pulses, but for heavy-handed pilots who would tend to land hard. Yes, we had one guy used to be a Navy pilot, used to be a carrier pilot, and he flew AWACS. His last name was Grasham, and so we called him Crasham Grasham because when he planted that E3 on the runway, he planted it with a vengeance. Like he was trying to catch a tailhook or something. I don't know. I'm not kidding you. We landed in Egypt one day, and I think the runway caught him by surprise or something. But we had ceiling tiles fall off the ceiling of the aircraft. It was horrible. My teeth hurt after that landing. Deck equipment, Open VMS. Yeah, here's an interesting thing about IBM 370. There's a variant of the IBM 370 operating system these days called ZOS. It allows you to run Unix on an IBM mainframe. This is essentially what it is. So why would they do that? Well, a lot of things have moved towards the virtual environment. vSphere, what we're doing. The military, U.S. military, is using virtual environments extensively. And VMS, IBM, those guys, they didn't want to miss out on that bandwagon. So they basically came up with ZOS that allowed them to carve out virtual environments inside of their operating system or inside of their hardware and wedge in a Unix operating system. Hewlett-Packard, HPUX, is Unix. Everybody understands how a network works. You guys have been on. I mean, do you really understand how a network works, or you just know that if I get on a keyboard, I can connect to things? But do you really know what's going on behind? How many of you have gone to any of the networking courses? Intro. So, okay, so now you understand. You all got that. Was Ken your instructor? No, who? Arlene or Eileen? Arlene. Okay. I don't know if she does the same thing on subnet masking that Ken does, where he fills the whole board up. No. Okay. He fills the whole board up with some kind of math, and I never did understand how that worked. All I know is I know how subnet masking works because I memorized it. Maybe that's the hard way to do it, but that's what worked for me. Other people, they can understand some of the formulas. Okay, we all know what a server-based network is. Well, it's basically there's a server and everybody connects to it and does whatever they have to do. It could be an Outlook server, or Exchange server rather, so that you can connect via an Outlook client to do mail. It could be a web server. It could be anything. Peer-to-peer, yeah, that's what you do when you do gaming, right? When you have a gaming session or something like that, and a bunch of first-person shooters running around. Okay, it can be used on many systems, functioning as all the things you want it to be, a client, or you can use it as a server. It can be standalone. In fact, there are various runtime modes in Unix, and one of the runtime modes is a single user mode, where it allows you to only have one user logged in at a time. What do you need that for? Well, maybe you're doing upgrades, to your system, and you don't need to have users on there, and you're going to do a reboot or something like that because you installed new hardware or something like that. You go to single user mode, nobody can log in, so that when you shut it down to reboot it, nobody has their work lost. Multi-user, like I said before, it's multi-user, multitasking. It's kind of and I mentioned this on Tuesday, I think, it really only services one user at a time, but just a little slice. And it does from user to user so quickly that it all seems like it's real time to you, but it's not really. Now, there are other applications inside of Unix that you can And you can do it in Windows too. You can set the priority of a particular application. Give it a high priority means it gets more of the CPU resources or the hardware resources, all, and the other users don't get as much. So Unix is a portable system. As you saw, it can be on a PDA like I had the other day. It can be basically in a cell phone. It can be on a laptop. It can be just about anything. So it's very portable. Linux is the one that really leveraged Unix's portability to a lot of things. Okay, what's the shell? Basically, it's an interface between you and the computer, the operating system. Not too much of that I'm worried about. This is how you would see it in a pyramid look. You'd be the user, you talk to a shell, your shell talks to the operating system, where the kernel is the one that's in charge of everything that's going on. And then the kernel is the one that communicates to hardware. So if you want to copy a file from a CD-ROM, you basically go to the shell, you do your copy command, because the operating system has already recognized the CD-ROM that you put in there that had a file system on it. And then you tell it to copy, and it basically uses the commands from the operating system to copy that file off of the CD-ROM to wherever you want it to go. Linux rather, is Unix-like. I've never have liked that term. I've always considered it to be Unix, and I think I said that the other day as well. It's original code. It supports POSIX standards. Are you guys familiar with POSIX at all? Okay. It was an effort to standardize various operating systems, and more importantly Unix, years ago, so that if your operating system was POSIX compliant, it would be more portable and data could be shared more easily from different operating system to different operating system. This is something that was pushed by the government, and though I'm not going to test you on all that stuff, but just know that it's a standard that was designed by the government to kind of create a uniformity and a level playing field among Unix operating systems, or operating systems of all types for that matter. We all know that Linus Torvalds was the guy that came up with Linux, started back in the very early 90s. And it can coexist with our operating systems. You can create a virtual system on your Linux box and install Windows into it, or you can create a virtual system on your Windows box and install Linux in it. So some pretty neat stuff can be done with operating systems nowadays. Okay, shell. All right, talking about shells. Back in 1977, not too long after Unix came to be, they developed a shell called the Bourne shell. It was written by a guy named Stephen Bourne. Not to be confused with the Bourne Legacy or any of that stuff. And so it was the primary method of communicating between the user and the operating system for many years. Then they came out with a C shell. It's kind of a play on SEA shell. But basically the C shell made the interface more C program-like, to where you can actually use various C syntax. You can type in various C commands and emulate what you would do if you're a compiler, a C compiler. And so there are a lot of programmers that like that and stuff like that. And then later on they came out with the Corn shell. That was back in 1983. And then in 1989 they came up with the Bash shell. Does anybody know what the Bash shell stands for? Born Again shell. It's a play on the first shell. But they spell it B-O-R-N. So that's the primary shell nowadays for Linux. Now, one of the interesting things that one of the easiest ways to tell if you're on a Systems 5, which is from AT&T, or a Berkeley BSD variant of Unix, is at the shell prompt. There will be always a prompt unless you modify the configurations for the shell prompt. If you're on a a AT&T Systems 5 variant, your prompt will be a $sign. If you're on a BSD variant, your prompt will be a percentage character. In both of those systems, you're logged in as a normal user, you'll either see the $sign or the percentage sign. Now that prompt can be modified, and we'll have an exercise one day to do that. And trust me, you can get it so screwed up that you don't even know where your cursor is on the screen if you're not careful what you're doing. But normally you'll have the $sign, and the cursor will be sitting there blinking right next to it. You're going to have the prompt provide you with a lot of information. It can tell you what directory you're in if you want to configure it that way. You can change the colors when you're using something like the bash shell, where it has the ability to change the color of the prompt. So there's a lot of different things. You can even have it tell you what time it is on the prompt. So it's totally up to you. What I find is if you're a person that's involved in logging on to a lot of different Unix operating systems, that it's good to have them, if you're using bash on all of them, to have each one have a different color so that you can easily recognize it. So if the prompt is blue and you're typing in blue, then you know you're on system A. And if everything is just black, and you can change the background colors in your shells as well. So there's a lot of different variants that you can put in there. Now in both of them there's an administrative user, if you will, and we'll get more into that later. It's called root. And the root prompt always has the pound sign or the hash mark, hashtag, whatever you want to call it. So you always know that you have access to as a root. When you're root, you're dangerous. You can destroy the entire operating system at root. As a normal user, you can't. So two things. One, you should never allow anybody to log into your system as root remotely, ever. They should be logged in at the console, which is the primary keyboard and screen, and that where they should be able to log in as root there. But everywhere else, they shouldn't. Yes?
Can you do a virtual version of the console, like on Windows?
What do you mean by a virtual version?
Well, basically, like if I remote in using remote desktop or the
Oh,
Turtle
yeah.
protocol, I can put in a /C, and it will actually force a console. So if somebody's logged in and using the keyboard and mouse, it'll actually kick them off. And now I have a virtual console session going for certain software, like they require a console session to put in key codes, etc.
Right.
Is there a way to do that in Unix?
Yes, yeah. It's got all the same capabilities, but what you want to avoid doing is allowing people to secure shell into your system
Right.
and log in as root. Because when they log in as root, who are they? What if 10 people know your root password? Or their shared system administrator responsibility. Now you don't know if it was Joe or Billy or Amanda or whomever that logged in and did it. That's why you always want them to log in as themselves first, and then when they SU, which is super user command, when they SU to root, then you'll see that in the logs that Amanda logged in at whatever time and then SU to root and then executed this command. Now, obviously, if there's 2 or 3 people that are logged in as root at the same time, that could be a problem too. But normally it's not. But you want to have as much logging capability as you can to know what really happened on your system.
Does it capture IPs for users, or do you have to have something that does that?
No, you can get all that. It's all in the logging capability. Depends on how you have it configured up. And there's other applications you can add on to it. There's firewalls you can install using IP tables, which is the natural firewall for, say, a Linux operating system. And I use one called Shorewall, which allows me to create a blacklist. And probably one day I'll show you my little private stash of bad addresses that I have, of where I've mapped out all of China, all of North Korea, most of Japan, and a few other countries I don't like. But it can be pretty extensive what you can get involved in, but when you stop and look at how many addresses are out there on the internet, it's pretty phenomenal. Okay, obviously to log in, you don't want to have open logins. Now in the early days of Unix, basically they just had a user ID and nobody had passwords. And then they realized pretty quick that you probably should have passwords. And we went down the whole evolutionary path of, well, the passwords are always available in the a certain file. It's called etc password, or PASSWD. Etc being a directory where a lot of configuration files are. etc is the command for it. But then they realized that was a problem, so then they created the shadow password file, which is a file that has your encrypted password in it, but it can only be seen by a root user. And even though if somebody can ever get into that point of the computer, you've already lost the battle. But it can always be unencrypted eventually. Okay, again, I was talking about it earlier. You can use Telnet, which I definitely frown upon. But Secure Shell is just as easy to use as Telnet and offers you all the capability that your entire session is encrypted. You can collect through network client software. Obviously, you can use something like VMware. You can use, X Windows. If I'm running X Windows on my workstation, and you have X Windows on your server, this is something like the remote console. I can just kick off an X session to the remote server, and I'll get whatever I'm logged in as when I log into the server back in my X Windows on my workstation. So there's a way of doing that. Though traditionally the communications for X Windows is not very secure either. Now if you tunnel it down Secure Shell, which you can do that as well, it works fine, and it now is double encrypted, if you will. Peer-to-peer network. There's all kinds of things you can do with peer-to-peer. One of the things they had a long time ago, and I never did like that much because it was a pain in the butt to manage and administer, was network file sharing, NFS. Now network file sharing is used in many connotations across the Windows world and stuff like that. But back in those days, NFS was the ability to share a directory or a partition to other systems. And for a long while, there was a university in St. Louis, Washington University, I think it was called, and they had these huge FTP archives. Everybody familiar with FTP? Not many people use it anymore, but yeah. Okay, it's file transfer protocol. But they would share these huge archives, and you could basically FTP in there and look at them. But they would share them so that you could, without being authenticated or anything, you could mount their systems on your computer. So when you looked at all your partitions, you'd have your normal partitions local to your computer. Then all of a sudden, you'd have this gigantic one of terabytes worth of data there. Of course, it was real slow when you wanted to get into it because you're literally transversing the internet to get to St. Louis to get to the archives in that directory. But it was kind of fun to play around with for a while, but after a while they shut it down, or at least shut down the free access to it. Dumb terminals, I mentioned that the other day. We used to run serial cables, and what are we at? Almost time to quit, huh? So I didn't get as far as I thought I was going to get. What's class is over at 1:15 or 1:45? Okay, I'm mixed up. I can barely see that clock, so I'm having to move my head back and forth, so that's probably what's messing me up. So anyway, Telnet, again, I don't like using it, but Secure Shell, I'll show you how that works, and of course I mentioned X Windows as well. These are some of the clients that you can use. Obviously, Windows has a Telnet client. TerraTerm, Putty, which I happen to like. I use Putty pretty extensively. And what's kind of unique about Putty is, see if I can get to a web browser here. Yeah. By the way, guys, I'm right-handed, but I have to use the mouse left. I got a lot of injuries in my back, and my 2 operations in my neck last year, cervical surgery, And basically my right hand's totally numb, which used to be my mouse hand. So I've now trained myself to do it on the left hand. Okay, you might know where that is. What the domain is? UK, United Kingdom, England. Okay. I'm hoping he still has this picture up because this guy is a typical geek. This is where you can pull down putty, and he's got this stuff, and it hasn't been, the source code hasn't been touched for a long time. Let me see if it's there. Nope. Team. Maybe he did take his picture down. Keys page. It's free. It allows you to do, basically putty does a secure shell, allows you to save a bunch of different configurations for different ones. It has a command line variant, or several command lines that you can use. PSCP, which is putty secure copy, putty secure FTP, a few others that I don't even use or don't even know what they are. Let's see, let's try here. There he is. There's your atypical geek. Pimples and all. I don't know. I don't think he's that young looking anymore because he's probably had this page up there for a long time. But he wrote a pretty darn good program, even though he never got it past version 0.63 or something like that. I know when I was working in DISA, all of my network guys and myself too, when I was allowed to touch the routers and switches, would use secure shell variant from putty to get access to their switches and routers and whatnot, firewalls. And so, I had about 75 people working for me at 3 different sites: Oklahoma City, Montgomery, and Columbus, Ohio. We managed somewhere on the order of 5,500 network devices worldwide, 24/7, 365. And they, almost to a man, every one of them used putty. And in fact, there was it was always kind of coy because you're not supposed to use open source software in the military, unless it's really been truly vetted. Well, putty now has been vetted. The source code has been verified as being safe. They've compiled it inside of the .mil domain and let people get access to it that way. But in the early days, we would use putty pulled right off of the internet, which is not always that smart to do, but it was the best program around, honestly. Very lightweight, very easy to use. Went right by it, didn't I? Okay, so that's one. XWin 32 is another one. Exceed, that's a commercial product. Provides X Windows capabilities, and it has more security than just plain old X Windows and communicating. It'll basically, you can crank up an X term from your server and connect to from a Windows box even, connect to a UNIX running X server and basically connect and get the X window and all that stuff. So it's pretty useful. Again, let's see, command line. This is just a picture of what a telnet session looks like, or a secure shell session would look like, and I'll show this to you here in a minute. Okay, I think we're far enough along. I can see if I can crank up a. See, there's putty. See if it'll work. First time you always use it, it's going to exchange a crypto key, and you can say yes or no, whatever you want. Okay, can you guys see that okay? Is it kind of small print? It's pretty hard to see. Do we need to cut a light off or something? Yes, you can cut one of the lights off so you'll see it better. Easier to see? Yeah, a little bit. Small. I'll have to work on that to get it bigger. Right off the top of my head, I can't. Yeah, maybe I can do that. Give me a second here. Go back to putty.
You can hit control and use the mouse wheel in the command window.
Huh?
Can't you use hold control and use the mouse wheel to zoom in on
I don't know. I'd have to check that. I know I can change the font with my settings. We'll try that. See if that works. Nah. There might be another way. Nah, it's not really showing me what I want, but I'm going to have to fiddle around with it because I know I can go into the putty configuration and select a font that's bigger and stuff like that. So, can everybody see it well enough right now? Is anybody having a problem seeing it? Okay, you're having a problem seeing it? Let me try it then. Let me see. I still got about 20 minutes, don't I?
Yeah.
So let's give it a shot. See if I can get into that thing and. Let's see here. Was it under appearance? Yeah, font settings. How about 20 points? Yeah, that'll work.
That's definitely good.
Yeah, there we go. Okay, back to session. Yeah, we're going to be able to see that one. Okay.
Is Telnet normally on port 22 or is it normally on port 25?
What was that?
Telnet, which port does it normally communicate?
Telnet comes in on port 23. Secure Shell uses, no, 21. 21. Is that right?
I thought it was 25.
Yeah, that was
No, 25 is email, SMTP.
Oh, that's right. Yeah, that is.
Secure Shell uses port 22.
22.
And 23 is Telnet, isn't it? Yeah. Yeah, and 20 and 21 are FTP. Okay, so this is basically what you get. I'm going to clear the screen here so we don't have that thing. But there's the $sign. So what type system is that?
Berkeley.
No.
No, not Berkeley.
Systems 5 AT&T. Berkeley's the percentage key or symbol. So there you are. You got your prompt, and you can do anything you want. Now, the simplest command would be something like ls. That's my directory. Tells you what directories are there. Gives you, the slashes are behind the directories, the files. Now, another command that you can associate with ls is a -l. Gives you the long listing. And I'll be explaining to you what all this here means. And obviously that's me, user and group of these two columns here. And this is a command or something that it's not owned by anybody right now. And over here it tells you if it's a directory, the first character only. And then the dash means it's a file. And then you might see one with an L right there about the middle. Yeah, it's that's a symbolic link. And I'll explain, if you will, a shortcut. Okay, a Windows shortcut almost. And so we'll get into all the WXR later on, but that has to do with the permissions on the file. There are three types of permission. There's the owner permissions, there's the group permissions, and then there's everybody's permissions. So as you can see, some group and everybody only have read. Yeah. So it's read, write, and the X is execute. So those are really easy. We'll use a command called chmod. Whoops, did I spell that right? Yeah, I didn't type anything in. So if it's chmod, interesting to see, from the command line you can get a lot of the syntaxes. Obviously that scrolled off the screen. There's a lot of different switches for the ls command. Okay, and how did I get to that? I just held the shift key down and hit page up. Did a screen at a time, page down. Or you just hit enter, and there you are. So a lot of those different commands are available to you. What was it? What is ls? Comes up, and if you see it says 1 in parentheses and a 1p, list directory contents. Okay, where does that come from? I do a man for ls, brings up the man page. Right there at the top, it says list directory contents. Now the ls 1 parentheses means it's the, and I'll have to break out the book on it because I can't remember now, but there are like 9 different possibilities that can be up there in that parentheses for commands. The 1p means user programming, so it's also carried under that manual as well. I hit Q to get out of it. So if I remember that switch, was it a dash A? I think it was. Okay, I get back to that same one, ls1. Now if I hit Q, it took me to another page rather than exit out of the program. This is the POSIX Programmer's Manual. So it tells you a little bit different information about ls, but pretty much it's the same thing. Hit Q again, that's it. There were only 2 man pages associated with it. So the interesting thing is that there are some little, everybody knows what an Easter egg is, right? In computers. For lack of a better term, we never called them Easter eggs in Unix, but they're essentially Easter eggs in various places in Unix. One of them has to do with the man pages, and I'll show that to you one day too. Okay, let's see. Back to commands. 2 categories of commands. Obviously the ones the user can execute, and then there are certain commands that only the administrator can execute. So let's see. Everybody knows ipconfig, right? Well, it's not ipconfig here. It's ifconfig. Can't find it, right? Well, because it's kind of hidden, but I can still use it if I knew where it was. It's because it's not in my path. That should be where it is. Yeah, there it is. ifconfig gives me all the information about my interfaces. Now, you'll see on this particular server, this is my server out on the internet, there are 3 different interfaces. Ethernet 1, or Ethernet 0 rather, that's your basically network interface. You got your loopback, and then TON 0. That's a secured, open, what is it called? I even forget the name of it now. It's not SSH, it's open something. Open VPN or something like that. Basically creating a tunnel between server on the internet and the server at my house, so that I can go down that tunnel and be encrypted all the way down.
OpenSSL?
OpenSSL, that's what it is. No, that's not it either. I'd have to look at it. It's OpenVPN, I think. See if I remember where that is. Yeah, that's a VPN. OpenVPN is what it is. And it basically creates an encrypted tunnel. And it can use, supports SSL and TLS security, etc. So it's a lot of different stuff. So basically, if I wanted to ping my house right now, if I remember that correctly, 10.8.0.2. That's my house. And if I wanted to, I can go and knowing my wife by going into that computer and turn on lights and turn them off around the house right now. I've done that on occasion. She's pretty much said I don't need to do that anymore. But and I used to, and I don't know if I'll do it. I haven't spent a while since I messed around with it. I have a web camera at home that sometimes I'll sit up and play with, and I used to set the web camera up and I'd point it at my aquarium, and then I would show how I could access that by creating a secure shell tunnel from this workstation here to my server on the internet, and then go down that tunnel that already existed to my local network and access the camera. Then I'd always have to warn the students beforehand. Anybody have an aquarium? Okay, anybody know what a clown loach is? No. If you've ever been in a PetSmart and you've seen these fish, they're kind of like a goldfish, but they got big black stripes, vertical stripes. They're clown loaches. Cool fish. And they get pretty big too. Our biggest one right now is probably about that big. But they have this bad habit of laying on the bottom of the tank on their side like they're dead. And sure enough, the first time I cranked up the camera in class and showed them, there he was, playing dead in the middle of the tank. But so there's a lot of different stuff you can do with this. And like I said, the neat thing about it, it's all open source. And all I'm talking about, none of it's GUI except for the fact that we used a web browser to access the web camera in my house that way. And of course, using secure shell, setting up the tunnel and all that crap was kind of interesting in the way you had to do that. So let's just real quickly, let me show you the root prompt. There you are, £, right here. So that's how I know I'm at root. Now, I just did a Control-D, or I can type exit, whatever I want to get back to my other user. The history, you see all the history just by using the up arrow. It's kind of helpful when you went and do multiple commands and stuff like that. Okay, let's see what else we got here. The date command, the cal command, and the who is command. Date. Pretty simple. Cal. Now, for example, let's do a man on cal, because I can't remember the switch. There it is. Yeah. So I want to do cal -3, 3 months. So real simple, just text, but it's available. It's not a GUI. You can't schedule something that way. But let's see, talking about schedules. Oh, let me go back to the root. Okay, one little lesson I want to teach you here real quick. Whenever you hit enter, whatever you got on the command line, right, wrong, or indifferent, goes in the log file. That's if you're at the command line. Now, I've already run su-, which tells me I want to switch to the super user, and the dash means I want to inherit his environment, which means it changes the directory and everything. But if for some reason I spooged something, and I'm still at the $ prompt, and I type in my password goes into the history file. So, lesson learned. Always look before you hit enter when you're typing in the password to make sure you're still at the password prompt. Because otherwise, you just typed it in the command line. If somebody does get in onto your account, but they don't have the root access, if they look in their bash history, they might find it.
Do they have to be logged in as that user? Or
They'd have to be logged in as you, yeah, to see your bash history file.
okay, so there is individual credentials or securities based on users and files. So basically,
Yeah,
if
yeah.
I can have my own file there that nobody else can have access to.
Right, exactly. Now I'm taking a look, nothing's scheduled, so that tells me that, well, I'm on the wrong computer, so you won't see it here anyway. Never mind. I was thinking I was on my home computer for a minute. Let's see, what was the other one? There's cal.
Who?
Ah, who? Yeah, who? Basically, I'm the only one logged in right now. But there's lots of things, lots of commands you can type. These are all the processes that I am running. Bash is one of them right now. But if I do a ps, whoops, psax, those are all the commands that are running right now. Now, to give you an example of how you can pipe information from one command to another, less is a command just based on a program called more.
Less is more, huh?
Yeah, less is more. More does basically the same thing, but less does more. But this shows you some of the processes that are running, and now it's in a viewer where I can go by line by line. I can go backwards. I can go to the end. These are all the processes that are currently running on that server. HTTPD, that's the Apache server that's running. Things like that. So there's a lot of things that are running. Got POP3 running on it, IMAP running on it.
But that's like a snapshot. That's not a live.
Yeah, it's a snapshot. Now, if you want it live, let me try to remember. I haven't used that one for a while. What was it? God, I can almost remember it. It's been 5 years since I've used it. Nope, it's not one of those. I'll show you. There is a way that you can see it live.
Oh, I'm sure.
No, it's not IP traf. Let's try this. Yep, I'm fat fingered today. IP traf. Okay, I'd have to resize the font there to make the screen a little bit smaller. And there's another one too, and I'll have to remember what it is. Right off the top of my head, I can't. But there is a way to watch it live, and you can see, what users are doing, how much resources they're using, stuff like that. All text-based. None of the GUI stuff. How we doing? We got 5 minutes or so left. Let's see. So I've showed you a few commands. What else we got there? This is basically what I just did. Okay. I'm not gonna show you too much about the multiple command entry right now, because it'll take a little more than what time we got left. I want to make sure I go through the slides here. But basically, you can take the command, a command like, well, I can show you a quick one. We know we can do ls, right? And let's say I want to just print out the words that have the characters A and I in them. Okay. This is how you pipe it. Using and it's not done. It shows it as a solid line, but it's the 2 dashes vertical like that. Do ls, and then I pipe it to a command called grep, which stands for get regular expression, and then give it the letters. And it just brought back one. I don't know why I brought that one. ANI, gallery text. Oh, because it's all in the same line, that's why. If I were to do it with an ls-l, it'll only bring back one. So that's how you can pipe from the output of one to another program to get your results. And you can daisy chain 5, 6, 7, 8, 9, 10, 11 commands on as much as you want. The other things you can do is I can do an ls-l semicolon, tell it to sleep, which is 3 seconds, and then I'll clear the screen. So ls-l, 3 seconds later, clears the screen. So that's not using standard in, standard out there. It's just you executing one command, executing the next command, and executing the next command. And they may not be related whatsoever. In this case, just to show you how that worked. Okay, clear command, just showed you that. Up and down arrows, I kind of showed you what it is. We already did what is. It's pretty handy. When I showed you the IF config thing, and I couldn't type it from the prompt, but I could still run the program if I knew the full path. It's because the way the directory structure is set, sbin are normally system files, binaries, sbin. Normal binaries, which are normally accessed by every user, like ls and cal, are located in the bin directory or the user bin directory. And there's also a user sbin directory. And to make it even more confusing, there's a user local bin and a user local sbin directory. But the real ones are either an sbin or user bin and user sbin or user bin or bin. There is a bin directory as well. So if it's in your path, and normal users will be set up with a path that's different than the root user. Now if I logged in as root at that particular time and I type in ifconfig, I wouldn't have to type in the full path because it would already be in my path. And well, I'll explain more on that later. We talked about the man page already. Okay, the exit command. I usually use a control D to get out and log out of my shell session. You can type exit if you want. So it's basically the same. The C shell is a little bit different. You have to type a log out. But for bourne, corn, and bash, exit or control D will work. And we already talked about these prompts. Percentage, the $sign are the normal user prompts. $sign being for systems 5, percentage being BSD derivatives, and then the £sign is the root user. PASSWD command. We're almost done here, so I'm going to skip that one over because we'll get that set up when you guys get logged in. And cat more, we talked more and less. I didn't show you tail. That's a little more involved, but it's a cool program. The head and tail, another one, the redirect. So we got to cover those next week once I get you guys onto the system. All right, I'll type in exit for the. Oops, am I in there? Okay. And that logged me out. Okay, so that pretty much wraps it up for this class. Next Tuesday, I'll be working with Roy today and tomorrow, and I'll have your images set up, and you guys will be able to log in, and from there we'll just press on with these commands and see what happens. All right, cut the light on the way out there. Thanks, appreciate it, guys. See if this stupid thing will work now.